take a look at a few problems from section 2.7. Let's start with number 3. Number 3, you're given a graph, and you can see the graph here shown in red, and you're asked to arrange the following numbers in increasing order and explain your reasoning. Well, the numbers that you're asked to arrange are 0, g prime of -2, g prime of 0, g prime of 2, and g prime of 4. Now again, these don't look like numbers right off the bat, but you have to remember that these are that the derivative at a point is the slope of the line tangent to that point. So let's take a look at our different values. Let's see, we got, well, 0 is obviously a number. Now g prime of -2. -2 is back here. G prime is going to be the slope of the line tangent here. Well, it's going to be a pretty steep positive slope. So the slope here is g prime of -2. How about g prime of 0? Well, that's this slope of this line tangent right here. How about g prime of +2? Well, g prime of +2 is the slope of this tangent line. And finally, g prime of 4 is the slope of this tangent line. The slope here is g prime of 4. Now, one of the things you recognize is that one of these is negative. The only one that's negative is g prime of 0. That has a negative slope to it because the function is decreasing as we move from left to right. So that's the most negative, so we're going to list them in increasing order. Well, that's the only negative. So g prime of 0 comes first. Now the other three slopes you can see are positive because they are increasing as we move from left to right. So the next number is going to be 0. Alright, now which is the least positive, the least steep of the three derivatives? G prime of -2, g prime of 2, and g prime of 4. Looks like g prime of 4 to me. If you look at your book, I think you'll agree that the line tangent to g prime of 4 is the least steep. I think next is the line g prime of 2. I didn't draw a very good picture here, but if you look at your book, the line tangent at 2 is going to be not quite as steep as the line tangent at -2. So I think g prime of 2 comes next, and g prime of -2 comes last. So again, what you're doing is arranging these in increasing order based on the steepness of the graph at that point, based on the slope of the line tangent to the graph at that point. Alright, next problem I want to look at is number 6. We want to sketch the graph for a function g where we have these stipulations on it. G of 0 is the same as g prime of 0, which is equal to 0. And what else do we want? We want g prime at -1 to equal -1, and we want g prime of +1 to equal 3, and finally g prime of 2 to equal 1. Alright, so these are the stipulations we want on our function. We want to sketch a graph of this thing. Now there's lots of different graphs we could sketch that'll make all this true. We have 0, -1, 1, and 2. So let's make sure those are on here. 1, 2. Alright, let's start with g of 0 equaling g prime of 0 equaling 0. Well, g of 0 equals 0 means that when x is 0, y is 0. So we have to be at this point. Now the other thing that's true is that g prime of 0 has to be 0. That means the line tangent to the curve at this point has to be a flat horizontal line so that the slope is 0. So let's keep that in mind, and we'll see how that's going to work. Now g prime of -1 is going to be -1. So the line tangent here, when x equals -1, has to be a negative slope. So we're going to have a negative slope here of -1. I'm going to draw it down here. I'm not exactly sure where we're going to want to put it. G prime of 1 is equal to 3. So when x is equal to 1, we want the line tangent to have a slope of +3. That's a pretty steep positive slope here. And g prime of 2 is equal to 1, so the slope of the line tangent at 2 is going to be +1. So let's see if we can make this work then. Maybe if we bring our function in, we'll bring it in like this from back here, and we'll bring it in like so. We want to flatten out here. We have to hit this red point here because we know g of 0 is 0. And so now we want to get really steep by the time we're at 1, so that we have the slope of the line tangent here at 1 is +3. And then the next thing we need to know is that at 2 we have a positive slope of 1, so we could sort of come like that. Alright, now I think you'll agree then that the slopes of the line tangent here at -1, the slope is, that's reasonable that it's -1. It's not, we don't know exactly, but it's close. The slope here at +1, the slope of the line tangent here, it's reasonable that that is 3. and the slope of the line tangent at 2, it's reasonable that that is a positive 1, increasing as we move from left to right. And the slope of the line tangent at 0, we can see, is 0. So there's one possible graph that satisfies those conditions on the function g. Next problem we want to take a look at is number 8. We have a function g of x is equal to 1 minus x cubed. We want to find g prime of 0 and the equation of the line tangent to the curve then at y. The curve y equals 1 minus x cubed at the point 0, comma 1. So the first thing we're going to need to do then is we're going to need to find g prime of 0. Now remember our definition, it's just the slope of the line tangent, so we're going to take the limit as h approaches 0 of g of a, which is 0 plus h, minus g of 0 all divided by h. And this limit is going to give us the slope of the line tangent to the curve at that point. So we have the limit as h approaches 0 of, let's see, if I put 0 plus h into my function, that's going to give me 1 minus 0 plus h cubed. Alright, so we just put a 0 plus h in for x there, minus g of 0. Now, that's just 1 minus 0 cubed, all divided by h. So let's come down here. What's that equal to? Remember to always rewrite your limit every step of the way. We're taking the limit as h approaches 0. Let's see, this is 0 plus h quantity cubed, so that's just going to be 1 minus h cubed minus 1 minus 0. That's just going to be 1 all over h, which is equal to the limit as h approaches 0 of, well, we can just take out the parentheses now, 1 minus h cubed minus 1 over h. Now the positive 1 and negative 1 add to 0, so we have then the limit as h approaches 0 of negative h cubed over h, which is equal to the limit as h approaches 0 of negative h squared. And so now this function is defined at 0. We can go ahead and put 0 in for our limit. It's continuous at that point, and we get 0. Alright, so it says then that the limit as h approaches 0 of f of 0 plus h minus f of 0 divided by h is 0. That tells us that the slope of the line tangent to the curve is 0. So whatever our function looks like, let's just kind of think about this. We don't have to be real precise here. We'll draw a better picture. But what we know is that the line tangent to the curve at 0 is 0. It's a flat horizontal line. We want to find the equation of that line. Well, that's not too hard to do. We can use our point-slope form. Remember that we're at the point a comma f of a, which in our case is 0 comma f of 0, which is 0 comma, what's f of 0? Well, we decided I think f of 0 is 1, right? Yeah, 1 minus 0 cubed is 1. So 0 comma 1. So remember we can use the point-slope form that y minus f of a is equal to f prime of a times x minus a. So y minus f of a, which is 1, is equal to f prime, which we decided is 0, f prime of a times x minus 0. And so we just get y minus 1 equals 0, or y equals 1. So it turns out we're actually up 1 unit here. This picture is no good. Let's erase it. And actually, let's just go ahead and look at the actual graph itself. And then we can draw a better picture based on that. If we plug in 1 minus x to the third and graph that. There it is. And now let's go ahead and put in the equation of the line tangent at x equals 0. We're at this point 0 comma 1, and we just said it's y equals 0. And no, we didn't. We said it was y equals 1. We said it was y equals 1. And there it is, tangent to the curve at that point. So that's the picture of the graph there. Looks something like that, where we have a slope of 0 of the line tangent, which again is f prime of 0. Let's try one or two more problems here in, what section are we in? 2.7. One or two more in 2.7. Let's try number 16, where we want to find, we have f of x, and it's equal to x squared plus 1 divided by x minus 2. We want to find f prime of a for any a. So this is going to give us, if you think of it really, it's going to give us a function for our derivative at any point a. We said that's going to be the limit as, not x, but h approaches 0 of f of a plus h minus f of a divided by h. Now, maybe off to the side here, let's do f of a plus h and f of a. So we'll kind of do these separate here. f of a plus h, what's that going to be? It's going to be a plus h quantity squared plus 1 divided by a plus h minus 2. Let's simplify this a little bit here, and then we'll plug things back in to our derivative limit. So we have a plus h squared. If we square that quantity out, you have a plus h times a plus h. That's a squared plus 2ah plus h squared, and then plus 1. And in the bottom, we just have a plus h minus 2. Okay, so far so good. Now what does f of a equal? Well, f of a is just a squared plus 1 divided by a minus 2. And so what we're going to need to do is subtract these two quantities. So it's going to get a little bit messy here, but we're going to take, let's just see so we can simplify it first. F of a plus h minus f of a is equal to a squared plus 2ah plus h squared plus 1, all that divided by a plus h minus 2. And we're subtracting from that a squared plus 1 over a minus 2. Well, we're going to have to get a common denominator here. And so I think we're going to have to multiply top and bottom of this function, we'll say, by a minus 2 and a minus 2. And here we'll multiply by a plus h minus 2 and a plus h minus 2. So again, things are going to get a little bit messy here. What does that give us? That gives us, well, let's just write it like this. A squared plus 2ah plus h squared plus 1, that quantity times a minus 2, minus a quantity of a squared plus 1 times a plus h minus 2, all of that divided by this common denominator now of a plus h minus 2 times a minus 2. Alright, so we got some multiplications to carry out here. We get, let's take the a through here, we get a cubed plus 2a squared h plus ah squared plus a. Take the negative 2 through, minus 2a squared minus 4ah minus 2h squared minus 2. Alright, so there's that. And now we're going to subtract in these parentheses here. Let's do this multiplication, and we're going to kind of run out of room, but let's see. Let's take the a through, and we get a cubed plus a. Take the h through, and we get plus a squared h plus h, and the 2 through, we get a negative 2a squared minus 2. And all that's being subtracted, so I did all that in parentheses of this multiplication right here. The a through, the h through, and the negative 2 through. Alright, all that then is over our common denominator of a plus h minus 2 times a minus 2. And so what do we have? We have a cubed plus 2a squared h plus ah squared plus a minus 2a squared minus 4ah minus 2h squared minus 2. Distributing the negative now, we get a minus a cubed minus an a minus a squared h minus h plus 2a squared plus 2. All of that divided by a plus h minus 2 times a minus 2. Is everybody with me? I hope. Now let's look at, we should get some things that fall away here. Positive a cubed and a negative a cubed. Positive a and a negative a. Anything else? Negative 2a squared, positive 2a squared. Negative 2, positive 2. Notice we're getting rid of everything that does not have an h in it. And that's always going to be the case with these limit derivatives that you're taking. Alright, so we're down to something that's not too bad here. It's kind of manageable. We have 2a squared h plus ah squared minus 4ah minus 2h squared minus a squared h minus h. Is that right? Yeah, okay. All of that divided by, let's go ahead and do this multiplication here. I take the a, I get a squared plus ah minus 2a. If I take the negative 2 through, I get minus 2a minus 2h plus 4. Alright, anything else that we can simplify here? Well, let's see what we can do. Actually, let's combine like terms. On the top, I have a 2a squared h minus an a squared h. So let's just leave me with 1a squared h. So we got rid of that and that. Ah squared, that's the only one of those. So plus an ah squared minus a 4ah. And that's all for those. Minus an h and minus a 2h squared. In our denominator, can we combine any like terms? Yeah, we have an a squared plus an ah minus a 4a minus a 2h, and plus a 4. Now notice again that we have at least one factor of h in every term in the numerator, so I'm going to factor that out. And that leaves me with an a squared plus ah minus, minus 4a minus, and let's see, then we get a minus, let's see, what are we doing? Factor an h out of here. So a minus 1 there and a minus 2h, all over that a squared plus ah minus 4a minus 2h plus 4. Now again, what was this equal to? This is equal to f of a plus h minus f of a. This was just the numerator part of our limit. We haven't taken the limit yet, but don't worry, it gets very easy from here. So we found this numerator part and simplified that, pulled that out. So now we're ready to take f prime of a, which is equal to the limit as h approaches 0 of this difference, which is h times a squared plus ah minus 4a minus 1 minus 2h, all divided by a squared plus ah minus 4a minus 2h plus 4, all over h. Well, we have this h and this h here. We can bring this h up and multiply by 1 over h, and so those h's divide to 1. So we're left with then the limit, f prime of a, is the limit as h approaches 0 of a squared plus ah minus 4a minus 1 minus 2h, all divided by a squared plus ah minus 4a minus 2h plus 4. Now this function is defined at 0, where h is equal to 0, so we can go ahead and plug the limit in, and we get a squared plus 0, so a squared minus 4a minus 1 divided by a squared minus 4a plus 4. And that, my friends, is f prime of a. And now for any point on our graph, if you want to let x equal a, you could just plug it into here, and this will give you the slope of the line tangent to the curve at that point. Okay, and that's all the problems that we'll do for this section. You'll need a password for 2.6 to get into the homework. And the password for 2.6 is subreption. S-U-B-R-E-P-T-I-O-N, and it means a deliberate misrepresentation, or an inference drawn from a deliberate misrepresentation. Subreption is your password for 2.6. Good luck. Actually, this is 2.7, isn't it? 2.7 password is subreption. Let me know if you have any questions.